And I'll hand it over to Frank for the recovery webinar.
Well, good afternoon, everyone. Welcome to the First Nations Launch Recovery webinar. I will be your host, Frank Noble. I'd like to make a little statement before we begin our slideshow. The following recovery presentation represents the standard aspects and skills practices used to perform this webinar and success by a high-power rocketry organization. If any techniques or standards are in question, please take note and bring it to the presenter's attention at the end of this webinar. Uh-oh.
All right. And just as a reminder to everyone, this is the main team, comprises FNL, Wisconsin Spacecraft Foundation. We have Kevin and Christine, the directors, main leads of our organization. Myself and Connie make up the main admin team for the competition. Megan also provides us some support with reimbursements as we get a little closer to launch weekend. Frank and Mark make our amazing technical team, and Bob Justice provides some additional support throughout the competition. Sorry.
Okay, during this webinar, we're going to be going over the rocketry recovery profile and avionics bay controls. It all starts right there in the brain of the rocket. The types of hardware and anchor points. Deployment, hardware, and techniques I'll go over on their strengths and where they should be connected, and how to achieve a safe recovery locating your rocket in the field. Here's a little example of a rocket taking off, as you can see on the powered flight on this flight profile. You have the person there with the weight of the world on his shoulders as the rocket ascends. Of course, they always say the body at rest persists in the state of rest, and the body in motion maintains the constant motion along a straight line unless acted upon a external force, which is happening right now as the power flight is ascending. And as the motor burns out, there's another action, and the reaction would be the person's hat would be flying off if he was inside the rocket. So that would be like your recovery system, your harnesses, your parachutes, and possibly a loose avionics sled or component that's not strapped down to your sled. And as we go to phase number 2 into the coast, we come around the top and go to apogee, and your drogue chute comes out at a specific altitude. And of course, during the deployment of your parachute, you have another action of reaction, of course, making sure all your batteries are strapped down. And your payload, such as your drone, is secured during this phase. And as we do the last part of the ascent in phase number 3 there, the ascent shows the main chute coming out, no less than 300 feet, of course, as stated in your handbook. Just want you to know that every action has a reaction in your rocket, so you can make sure everything is tied down in your rocket, especially your recovery components. Avionics check. Of course, always use fresh batteries. Batteries will optimize your operating voltages in your altimeters and your GPSs. Redundant recovery, of course, system is probably beneficial to your rocket. Also, it's also benefit to your energetics that you use in your rocket too, as far as your recovery. As you can see in this picture here, we have a 400 milliamp LiPo battery, which is strapped down by a 3D printed envelope right here. And this in figure 1 here also we have a 9-volt battery strapped and taped. Always double down on batteries and components that you think are going to be flying out. This is just a straight flat 3D printed sled. And in figure 2, this is the back side of it with the avionics. I just have one avionics on this side and a smaller one on this side here. and you can tell all the wiring is strapped down and contained onto the sled, so nothing moves. All terminals are rechecked for tightening down and secured. Always mount altimeters using a non-metallic standoffs, which are on the bottom in this figure right here, to avoid damage of delicate components. Don't ever try and mount your electronics straight down to the sled, because you may crush the intricate components that are on the backside. Sure wires are secured to the altimeter. The Phoenix connections, which are the green connections right here, are called the Phoenix terminals. Just perform a gentle tug as you're tightening it down, and always try and use stranded wire. Try to avoid using solid wire, because they may break during flight or during installation of your sled. Understand the program of the audible sequence of all altimeters that you use. Here's a typical wiring. Always wire it right. Double check and recheck. It's a good idea to use color-coded wires for, let's say, your drogue. You have 2 wires here. It doesn't matter the polarity on most altimeters. You can either tag them or use different colored wires, knowing that this wire is going to be going to the booster and this wire is going to be going to the main, where the sustainer is. Always use a switch 2 also. Make sure the wiring is correct. Pretty simple wiring diagram. Always review the owner's manual for proper function of the wiring and the sequence of its operation. Restraint recovery hardware is available at most hardware stores, outdoor sporting shops, and rocketry vendors. And also, I think camping and hunting stores also carry some of these objects too. Some quick links are stamped. You'll see a little stamp on the side of this turret right here. It'll say a certain working load limit. And basically, as you can see on the side chart right here, 1/4 inch type quick link carries an 850-pound working load, which should be sufficient in the rockets that you will be flying. If you want to go one step up further for 2,200 foot for a 3/8, it's getting a little big right now. But 1/4 inch is pretty safe to go by for a attachment to your recovery harness. The basic, let's see, number 9. Well, number 1, of course, we have the a smaller type recovery harness like this, or a quick link. And of course, we have the open link eyelet, which is not permitted to be used in high power rocketry. It's only permitted in mid to low power rocketry. Your best bet, since Mars and Moon are using a little bit larger rocket, I recommend U-bolts. They hold quite a bit of weight, at least 2,400 pounds. Here's your forged eye bolt. And the forged eye bolt says it is rated, got it somewhere here, not as much, but it's good enough for nose cone deployment. And of course, you can see the open eye is only rated at 700 to 100 pounds, which is not very, very strong. The steel eye bolt, I think, is rated to 650. Stated right here. Not as strong as the as these U-bolts, but sufficient for the type of rockets we're going to be flying. And then you have the swivel. You have the swivel type of retention system like that. It's fine. Do not hook these. Try and avoid not hooking these up to load points in your rocket, like your bulk plates in that. This is fine for your parachute. That is mounted from the parachute to your recovery harness. That is fine, just so it doesn't spin. And of course, these are your basic rocket parachutes. The safety code of both NAR and Tripoli and the National Fire Protection Agency, which allows us to actually fly rockets, require the high power rocket mainly to be flown only if it contains a recovery system, which is a parachute. For most high power rockets, this goal is achieved by using a parachute and is deployed when the ejection charge is programmed or at the point of apogee. Of course, we have the elliptical type parachute that everybody's favorite. Then we have the parabolic type chute. It's a little fancier. This chute here kind of avoids a little bit of the drifting as it goes laterally. And we have the X form, which brings down a rocket pretty quick. It's a good chute if you want to use it as a drogue. And of course, we have parachute descent rates. Rocket apogee under the small drogue parachute using dual deploy. We recommend it's a little lower than this. Oh no, it's 50 to 70 feet per second, 34 to 47. That's correct. We might have the new. No, we got a 15 to 25 feet per second. That's safe. I like that. Of course, you can go with the formulas if you wish, or when you're into your rock sim will tell you how fast your rocket will descend in your rock sim descent calculator. Don't forget to keep in mind what the winds are going to be doing, because it's going to travel a little bit quicker as it hits the ground laterally. So keep that in mind, not just always the descent rate. Always formulate your descent rate with the winds that are happening in the conditions of your flight. We'll move on to the harnesses, types of rocketry recovery harnesses. As you can see in the top one right here is a tubular nylon recovery harness. 1 inch wide, braking strength is 4,000 pounds, which is pretty good. They're usually all military grade. I have a little link right here, and this particular tubular is from Blue Water. They sell them at 30-foot lengths. They're only like 45, 50 cents a foot compared to your Kevlar strap, which is 90 to $1 a foot. Of course, Kevlar straps, they're heat resistant, strong thick synthetic fiber. Of course, it's all related to aramids such as Nomex. Tubular nylon, it's pretty good for resistant heat, what we're going to be using it for. The Kevlar down here, very strong, hard to break, hard to cut. If you had to get it down from a tree, you're probably going to more or less break a branch than break the Kevlar strap. And of course, in the middle right here, we have just the regular nylon flat webbing. It's good enough. It's got 38-pound load weight on it. Most of these strappings of these nylons right here, except for the Kevlar, you can buy at sporting stores, hiking stores. They have this in bulk rolls if you need to. See, okay, parachute length of recovery harnesses, especially during apogee deployment phase, should be at least 3 to 5 times the length of the rocket. This is the most important part of the flight. As the rocket comes over the top and descends, it's going at a pretty good velocity sometimes. Between you're pretty good, 5 to 20 miles an hour. Some might get up to 40 to 60 miles an hour on deployment as it descends after apogee. Providing this length will ultimately cause a drag as the harness unravels out of the airframe, reducing the velocity, of course, with the rocket during deployment. We don't want your harness to be too long. This is a little bit long. Sometimes the harness, as it unravels and the rocket passes up the parachute, you could get a zipper in your tube, and we'll show a zipper here in a minute. Of course, this is probably pretty normal length for a 5.5-inch rocket right here. As you can see, it's in the here's the drogue and here's the main that came out. This is a typical avionics bay setup. It's a little elaborate, a little detailed. As you can see, it has the all threaded rod here. It has the bulk plates on the end. This particular model has the U-bolts on it. And of course, we have the optional deployment canisters on each end of the bulk plates, one for the drogue and one for apogee. And this stays with the sustainer of the rocket, of course. And of course, you have your vent holes and your power switches and your band right here, your vent band. I think a few years ago, I used to have a price on this. I think this whole thing costed maybe $25. Okay, of course, you can order your own through Lock or other vendors too. This is a particular Lock setup right here with the sled. Everything is epoxied in. And of course, you can get a 3D printed one. You can make your own 3D printed sled if you want. Of course, you have your switches right here, which are aligned aligned with your airframe in your avionics bay. And of course, at the top here, you can get a free 3D file from RRC3 and other vendors too. They'll send it out, and you can just plug it into your 3D printer and do it yourself. I got a bunch of links right here that you can click on for that main reason. And of course, some like this altimeter sleds in Active Aerospace, they actually make this whole thing for you. Excuse me. And you tell them the particular diameter of the rocket that you needed for your avionics bay. Make it quite interesting. Here's your typical deployment setup in the avionics bay. I call this the a satellite deployment canisters, where you just have wires come out right here. And of course, each wire is taped or has a plug in the hole with either putty, or you can use silicone in these holes. And this is one satellite end for the main. And of course, here's your altimeter connected to another hole of the bulk plate through your avionics bay. And it's kind of taped to the side wall of your booster section. And I sometimes use canisters right here that hold this charge on here. This is a cardboard type deployment charge canister. And it more or less pushes out the rocket and all the recovery systems. And of course, we have terminal blocks here to separate the two so they don't get caught up. And if you decide to put quick links in between, that's me too. They always work as long as they make a good connection to your avionics bay. And this here, we probably won't be doing this on this competition, but this is a head-end dual deployment setup. Very informative link right here if you want to click on it later. It shows you how to put the avionics in here, and your recovery parachute sits in the nose cone here with your harnesses and everything. That is if you have a very short, high-performance type rocket that doesn't allow this sustainer to be in the rocket at all. So your recovery all stays in here, avionics will be in here, and it works pretty well. This part here is recovery harness connections to your booster section. And in figure 1, we call this the Y harness. It's connected to the centering rings, connected with the either eye bolts, or you can have them connected to the U-bolts, as shown in other pictures here. And of course, we have the minimum diameter type setup with us that you cannot actually. This is actually the motor centering ring right here, so it's not feasible to put a connection here between a eye bolt or a U-bolt because it's too small. So what is applied here is a epoxy the retainers, the recovery system to the motor mount, or to the motor tube actually. We usually use 2 of those, one on this side and one on the bottom side. So it comes out like this here in figure 5. And that way everything is contained within the motor tube, and there's no deal with the rings or U-bolts. And of course, this is how it's tied right here. In figure 3, of course, it's got the Y harness accompanied with a bowline knot or a figure 8 loop knot to secure the remaining harnesses, and we'll show you those knots in a little bit. And I have a little link for those too. Oh, and this is what you got to watch out for nose cones. If you're buying from a vendor and you're not going fiberglass, you may have to go with a bulk plate, or with Lock Precision, you have these plastic cones, polyurethane cones. As you can see in this figure here, there's a broken tab on this one here. So this one was devised with a sewing a little recovery harness, a little nylon strap in there through the nose cone to make a more robust connection. And of course, if you have a setup like this, you can drill a hole and put your quick link right through that hole. That's a pretty good connection, because this little tab right here, do not use. That will snap off on your first flight. Of course, we have a different design here, bulk plate nose cone with 2 holes on tabs like that. Double it up. So it's best to double it up. Also, you can if you desired to, I'll show you in a different picture. Of course, these are the tabs that come in. Some model rockets do not use these tabs. They will snap off under certain velocities if your rocket is coming in hot or if it's coming at a high velocity during your main deployment. And of course, I have all these links right here for a bowline knot. Very useful. And we got the double figure 8 knot, which is very useful too. Not very hard to get used to it, and it's kind of fancy. Of course, securing the tail end of your knots is beneficial in keeping it connected. Like I mentioned in the slides before, some of this hardware, like Kevlar and the nylon tubular, they untie easy, but they don't untie by themselves easy. They untie if you have to untie it yourself manually. But I do suggest on taping the tail end of the recovery end of the nylon or even Kevlar, just as shown in this picture here. And of course, figure 8. This is a figure 8 on it. You can do it twice. Kind of makes a robust knot. And of course, this is a single half knot, which works good. As long as you tape the end of it, nothing's going to happen. If anything is going to come apart, your U-bolts will punch through this bulk plate if it had to, or just come loose. This is a very secure recovery system right here. Of course, you have your European, they call this Euro connections right here for your deployment charges. This, of course, is a redundant system. It's a backup for the primary and main for the drogue. Of course, deployment canisters positioned directly forward of the booster section is a good idea. They don't show it on. They show one right here, and there should be another one right here, not in this photo. If you want to use these deployment canisters instead of the cardboard tubes, which are in this figure 1 right here. These are the satellite ones I was talking about, where they're taped to the inside of the wall of the airframe. And I have like little connecting tubes underneath there, which are 1/2 inch, I think PVC type water connections that I snap them into so they stay right where they are. And your injection shoots out towards the recovery system and your recovery wadding dog barf, if you want to call it that. Of course, here I was going to mention about you can cut off these end bulk plates on the polyurethane nose cone and put your own bulk plate in there with your recovery system also. These are extended so you can add weight to the nose cone and certain types of motors that you use on rockets, on high power rockets. It's very useful. Also, when you are always put the bulk plate above the shoulder of the polyurethane nose cone. That means it has to go above right where it's painted right. Oops. Cool. Apply the epoxy and the bulk plate just above this shoulder, okay? Because if you put it anywhere it's on the shoulder, the epoxy may heat up this polyurethane and it'll warp it, and you won't have a good time trying to fit it on your airframe. Of course, picture 3 shows a pretty good severe zipper. That's what a zipper is. That's when your rocket comes in hard and it deploys late, or it deploys early on a premature deployment as it goes up. This usually happens, as you saw on the first slide, when your cap falls off, when the motor quits burning. Well, your 2 separate parts, the sustainer and the booster, could come separate also, and this is what will happen too. You get a zipper. Recovery, pyrotechnic recovery devices here. In figure 1, we show 4F black powder provides the peak performance during deployment. Figure 2, of course, we have the canister type bulk plate mounted on the end of a bulk plate right here. We have a latex finger, which provides a pretty good pressure in your oops, where we go, inside your compartment of recovery system. It's not as I don't want to say violent as a canister or a cardboard tube, where you don't know which direction it's going to shoot. But this one here will provide a good pressure relief on your recovery system. All this is a latex finger wrapped with a igniter in it with packed with gunpowder. Of course, we have the cardboard tube. Pretty familiar with everyone. There's a 3 on this one, which is a 3 gram. Over 3 grams of black powder. And of course, the good old homemade one, if you want to make one, it kind of resembles the latex one. You can wrap it in paper, fold it up real tight, and use that for a deployment pyrotechnic charge also. Of course, here's your cardboard tube that is used just hanging there as a satellite. Of course, in 3 and 3A is an example of a simple deployment paperback that provides adequate ejection just for 4-inch rockets in 3 and 3A. Nothing bigger, please. Oh, these are the CO2 cartridges. They work very well. I haven't used them myself. I've seen a lot of people do use them. These devices are controlled by the altimeter in the avionics bay, and they're mounted outside the, or actually through the bulk plates of each avionics bay. Deployment is activated, which occurs inside a designed airframe to deploy the recovery harnesses. And this is the igniter. It goes into this bridge right here. This is the plunger actually. And in this plunger, there's black powder, very small amount of black powder. And these parts are all screwed together like this. And this spring holds this little point clear. And there's a little this air canister right here, the CO2 cartridge right here, has a little sealed disc on the end of it right here. So as the altimeter says it's time to go, it'll light this igniter, and this little pointy end here will go forward and burst this canister, which is the seal over here, and all the air will come out of here. And they do come in different sizes for the size of air pressure you need, anywhere from I think from 2, 3, 4, 5, 6, 7, 8 grams of black powder equivalency. They're pretty interesting. Of course, here's your canister type mounted avionics bulk plate. And these they don't make anymore. I should take this out. I don't know why, but these usually are filled up with black powder, and you can hook these up to your avionics bay or your altimeters also. Here's some more external type recovery devices, which we're not using Jolly Logics this year. Jolly Logic is a altimeter and a release mechanism all in one component. It has like a rubber band that goes around, and there's a solenoid in between. You can set your to release this rubber band, which is wrapped with a parachute. This is a chute protector that's around the parachute. And you can set the altimeter to 400, 100 feet, 1,000 feet for it to release this rubber band, and it opens up your parachute. Everything is by external. It sends out, it's all outside the rocket after apogee, and it deploys your main chute actually, not your drogue. Your drogue usually is controlled by your motor ejection part of the rocket. Of course, figure 2, we have a cable cutter here. Kind of works on the same principle as the CO2 cartridge. It has a igniter, has a little black powder inside, and it has a little knife inside here. So when the black powder, when it gets signal from the altimeter to go, it lights the black powder, and the knife cuts this plastic tag right here. And it's set up the same way as this Jolly Logic. They should not be a tender descender. We don't use those. We're not looking at tender descender. And it operates the same way as this Jolly Logic does. It releases the chute inside this chute protector. Preparation of a chute. There's different ways that people fold the chute. This is supposed to be the proper way to doing it. Always unravel your chute and do it in a spot where it's not windy, inside your car. I don't mind you prepping your rocket somewhere else if you had to, but try and do it out of the wind if you can. Avoid tangling these shroud lines. These are called shroud lines coming off the canopy of your chute. But the typical is to fold it 3 or 4 times laterally. Do a little S curve with your shroud lines. And this thing is way too big for my screen. Fold it in half and roll it if you need to. If you got to roll it very gently. And once you've had that roll off, lay it to the side. Of course, take the rest of your recovery harness that is connected to your booster and put it inside your rocket. Just drop it inside. Of course, first of all, put your dog bark or your cellulose inside the rocket first, where the motor is going to be dispersing hot gases, so it doesn't hit your recovery harnesses. And then kind of just drop your recovery harness inside your booster section. And after you get to the point where the chute is supposed to be attached, attach your chute and your chute protector to the quick link harness points, and wrap your chute protector around the chute and install it inside your booster. Put the rest of the recovery harness inside the chute. We have different harness procedures. Some use a tape like this, so it all fits inside your rocket, very convenient. That's just one layer of masking tape. Don't try and tape it 6 or 7 times, just one layer, because we want this all to unravel, to break off and unravel just from the pressure points of the sustainer and the booster as it separates. Okay, you got to keep your rocket hooked up together. Rocket Community offers these shear pins. These are 256 shear pins, which keep the booster and the sustainer together, as the picture showed in the beginning, where the young man's hat falls off his head after the motor burnout. This keeps these two parts together, because there is a forces that will separate these two parts between your switch band and booster and sustainer section. To get at your avionics easier too, you can use rivets on the sustainer part here, because this will stay on permanently as your rocket separates. Your shear pins usually go in this booster section here and pulls everything securely until the time is to deploy your either nose cone or your sustainer from your booster. And this is a typical installing a push-in type shear pins, and it is pushed and inserted and secures your, this is a nose cone part here, secure your nose cone. And some come with the threaded type, where you have to thread it in. Make sure you have the right size drill to thread these in. Too loose is not good. They could fall out. Make sure it's undersized, of course, and make sure I always drill a pilot hole for your shear pins also. Rivets is a kind of push and lock. These spread as you push it in and locks your sustainer into your avionics bay, so it won't come apart at all. Locating your rocket. This is the manual way. You and your team members should watch the direction your rocket lands all the time. I don't care what kind of fancy GPS system you have. Always watch your rocket where it lands, because sometimes your GPS might get a glitch. It'll come and go sometimes, or you might not get connected right away. When you see your rocket land, mark in the gravel where a straight line where it landed. Take a picture of it with your phone where it landed. You could get on your phone, and there's an app on there for a compass, and mark the lock the direction that your rocket landed, and use points like a tree line, a pole line, tents, canopies, cars. Hopefully they don't move on you by the time you walk out there, or even the range head have some flags up sometimes, and look behind you and in front of you and keep that straight line. This one here, to enhance the manual technique. Now, this seems kind of silly, but it works very well. Have a person who has a line on the rocket, which is this guy here in part A, stay at the location where you saw the rocket go down. Center the person to retrieve the rocket. Walking a straight line with directions from the person, using a radio or the phone, or wave left or right. If the terrain is obstructed with brush or small ditches and lines, have the person carry a small marker flag or a 6-foot white PV 1-inch pipe, which is very convenient. You can see that against the green background or brown, so the person can see you in the B location and the A location. Taking a video, of course, which I mentioned before about descending rocket, using a smartphone and the compass, as I mentioned before, and following the rocket's direction, landing and keeping a lookout for obstacles and maintaining a straight heading with landmarks observed in front of you and behind you. Always assume the rocket may have landed further than you perceive. Guarantee it, it's always further than you think. If you think you're getting close in the area because your GPS or your RF signals went out, turn it back on. You may get another reading. I just want to tell you that the next couple slides here, I had a rocket that went 8,000 feet. I go, oh, I'll find it. I have a tracker. I was going to drive to it. Well, I took my eyes off of it. And 40, 50 seconds later, I went to look up the sky. I couldn't find it. And I didn't know where it landed or anything. Dumb me, right? So I couldn't get a fixing on it with my RF because all kinds of farm machinery were going on. And also power lines were in the area too. Just your typical 17,000 volt distributing lines were giving interference. So I lost this rocket. I looked all over. I tried a drone thing, thinking where it went. So I went back, after looking for it for 2 hours, I went back to my prep area and I asked somebody, hey, did you see where my rocket landed? They said, yeah, between that pine tree and that silo, way over there. I go, oh, you're kidding. There you go. So anyways, after using this device here, I couldn't get a reading. But after they told me where it was and I drove a mile, I finally picked it up. Farm machineries are all done doing their cultivating and everything, and everything started working real good. This unit here, they don't sell anymore, but they do have it on eBay and Amazon. They're used, but they work very well. Yagi directionals, they work very well. Make sure all these units, you look where your rocket lands. We have the featherweight, which works very well. I've been in some places where they have force, and these work very well, almost like anywhere from 8 to 10 miles away. And of course, we have the egg finder GPS tracker, very affordable, but this is what you wire yourself up. You're talented at soldering and following instructions. It's a very useful GPS locator. I suggest that. Okay, safety. Very important. Sometimes locating and recovering your rocket can be a challenge. Be patient, take your time, stay focused where the rocket landed. I don't know how much I got to say this. Just look where your rocket landed. I don't care if it landed in a tree or a power line, so make sure you know where it landed. Avoid hazardous obstacles. Taking a buddy with you on the rocket recovery adventure is encouraged. Wearing proper attire, hiking shoes, leg coverings, pants. Take some water with you. Communication device. What we're going to be doing is probably getting someone's contact number at the field. So if you're gone for more than probably 30, 40 minutes to an hour, we're probably going to call you, or you should check in with us so we know that you're still around. Because someone might be finding your rocket and they might have brought it back and you're still out hunting for it. When you do find your rocket, please put it together. Put the chute back in, put your turn off of course, the altimeters, put your recovery harnesses, and put your parachutes in and walk back with your rocket on your shoulder or carry it. Because if you're carrying it with your harnesses hanging out and your chutes are hanging out, you're going to get caught on something. You're going to trip and fall, and I don't want you coming back with running makeup. How's that? Okay, wearing proper attire, of course, hiking shoes, leg coverings. Let's say, do not attempt to recover your rocket that will result you in being in an unsafe situation by climbing a tree. We have poles, water recovery. We may have a boat out there to get your rocket if it lands in water that it should not be in. Call the head launch range to coordinate the assistance, and write your contact information on the rocket in case someone else finds it. It's a good idea to write your phone number on the coupler part of your rocket, like right here. It's a good idea. Phone number, cell number. And someone can contact you and say, hey, I found your rocket. How much money are you going to give me? No rewards. Don't do that. Anyways, we do have failures that happen. This is a CATO, catastrophic takeoff, right here. Of course, the motor's burning and it overpressured on top, and the forward closure went on this rocket. And of course, here's me trying to get our rocket out of a tree for a poor fellow that thought he was going to lose it. And I did get it down. Do not recover a rocket if it's in the pole line. We will call somebody else to get that down for you. And the story I was telling you about when I lost my rocket, there it was. It landed in someone's front yard. Nice lawn and everything. They weren't home at the time, but I did have my phone number on it. And I was just so glad to find this because we're talking some big bucks right here. Motor casing, cameras I had on it, and altimeters. So yeah, so always keep your eye on the rocket where it landed. And that concludes the recovery webinar. Any questions, anyone?
Hey, Frank, what's the typical wire size for those wiring up those altimeters and such?
I suggest either 18 or 22 stranded wire. 18 is perfect, 22 is a little thin, but it works if you got a lot of wiring to do. And it doesn't pinch real good, you know, when you're putting everything together on the sled and you're sliding it in.
Thank you.
Did I miss anything? Anybody have any concerns or questions that I might have missed? Anybody got any better ideas?
Frank, it's Scott again. I might have missed it on those plastic rivets, those shear pins. They shear from the ejection charge, or
Yes, they do.
okay.
Yeah, these shear pins, yeah, they like even just 2 grams of black powder will separate those on a 4-inch rocket. Yeah.
How many are in there going around that? Just 2?
Yeah, I usually kind of go 2. I'm always scared of the rocket not deploying, not putting too much black powder in. I usually go 2. Depends on the size of your rocket, like this Mars or Moon rocket here. I would suggest how many do I have in here? I have 4 in this one here. Of course, you use like 5-6 grams of black powder in that, but it always comes back.
Good.
But typically, like a 4-inch rocket, 2 are fine.
I have a question.
Yes.
So it kind of goes off of the shear pins. So if we're using those in a cardboard airframe, would you suggest reinforcing those where those are located, where we mount them?
Yeah, you can drill your hole, pre-drill your holes, and you can put like CA or epoxy in around the hole, and then sand it so the coupler will fit nice and smooth.
Gotcha. Thank you.
Yeah, I've had a lot of cardboard. I have a lot of cardboard kits, and yeah, they don't zipper too bad. But I suggest putting the yes, either CA or the epoxy in the hole and just toughen it up a little bit. Be fine.
All right. Thank you. And I do have another question. So
Sure.
with the method of mounting, I guess, that our team is doing for recovery. So mounting the shock cords. So you had listed U-bolts and the I-bolts. We're actually going with an alternate method. And I want to make sure that, we're not going too far out. But rather than mounting them at 2 points, we're running the shock cord entirely through the avionics bay. And then we're using like cable clamps on the top and bottom to keep it in place, keep it from sliding. But rather than creating stress points, because we've decided to 3D print. So to minimize stress points, we've decided to run it completely through and then just hold the av bay in place using cable clamps.
What's keeping the av bay from sliding?
The cable clamps. So there'll be a cable clamp on the top and the bottom.
Yeah, I get it. Okay, just as long as those cable clamps, are they going to be on the inside or outside of the AV bay?
I'd assume the outside.
Okay, also because I don't want anything metallic flopping around Okay, cool. All right, I get you. I
Cool,
follow you.
thank you.
Pretty cool. Any other questions? Well, thank you, everyone. I hope you got some valid information. If you have your own ideas, great. If you have any questions, contact me or Mark. It'd be great. Thanks for attending.
Thank you.
Thank you, everyone.